Hello, welcome to my third presentation, Module 3 on Algebra Automation. Now this time I want to give a different flavor, a different version. It's written in JavaScript, hence it is a JavaScript AI developer course. In this developer course, we solve systems of linear equation using substitution and elimination. And again, from the previous video, let me give a recap. The substitution method is used to solve systems of equation by expressing one variable in terms of the other, and then we substitute it into the second equation. Now, we solve for the remaining variable, and then we plug the found value back into the original equation to find the other variable. So essentially, that's how the substitution method works. Now, in the elimination method, well, it is used to solve systems of equation by adding or subtracting equations to eliminate one variable. Now, how it is done? We multiply, it could be one or both of them, of the equations, so that the variable cancels out. And when the equations are added or subtracted, the equations here, we eliminate one variable, and then we solve for the remaining variable, and then we use the substitution method to find the other variable. So we could add an additional feature, or the program has an additional feature to understand the graphical representation of the systems of equation. Now let's try to build the application. By the way, the reason why we're choosing JavaScript is we want to make a web page out of the Python code in the previous video. Now in the previous video, in the Python version, I have listed the code that would generate essentially the output for the substitution and elimination method. Now all you need to do is to copy this lengthy code, and then you can choose your AI so that this could essentially be converted to JavaScript. And I have used DeepSeek here to generate the JavaScript version of the code. Now, I have pasted it already in IntelliJ, and I have made a folder here. The folder is named Systems of Linear Equation, wherein we make several files here. That is the index.html, the JavaScript itself. So this is the converted version. This is in JavaScript. So essentially the Python was converted to, or it was converted automatically into JavaScript. And we have an additional file to be created, the index.html and the styles.css. Now, if you are not familiar with web page development in JavaScript, HTML, and CSS, don't worry, because I have a video for JavaScript development. So all you need to do is to go here to my page, Micro Mananghaya, and then you will find in the playlist that I have a JavaScript developer course. Now in the developer course, I have some introduction to JavaScript, flow control, and I have discussed list in JavaScript. Of course, how to make functions in JavaScript, and how to utilize APIs. And there will be more videos that will be incorporated in the JavaScript AI developer course. But for now, you can examine that and give you a working knowledge on how to use JavaScript in creating web pages. Now let's try to get back to our project. Now here we have identified again index.html. Let me try to explain it, but before that, what's the HTML? It's a hypertext markup language. Well, in summary, that will give you the structure of the whole web page. So let's try to examine the structure of the web page. So we have UTF-8, we have viewport, the content width, device width, and the initial scale, which is 1, and the title of the program is Math Scavenger Hunt. Okay, so we give a link to the styles.css. Now, what's the style CSS? Well, as you can see, if you try to examine it, it will give you an idea that it is essentially the style of the web page. So this will entail the styles and the layout for the web pages. Like for example, it has a font of sans serif and it's Arial. We'll try to discuss that more, but for now, let's go back to the structure itself. So we have to have a link to the style so that the web page is quite presentable. Now, of course, there are certain links here. Like for example, you need to use catex to present everything in human readable form, so in somewhat a version of latex. Okay, so we have the HTML head section. Those are essentially links. So after the heading, let's try to discuss the body of the web page. Now we have a class here, game container. Now the H1 here, where we can examine what the H1 is. H1 is the highest section level and H6 is the lowest. So by default, heading elements created a block level. So what's H1? That's probably the largest. So because it's the highest section level. So let's try to see what this H1 looks like. So all we need to do is to open the program, the browser. Here it is Chrome. So as you can see, we have a title, Math Scavenger Hunt. So Math Scavenger Hunt, it's quite large and it's bold. Okay, so let's try to follow the web page. So we have a class progress container. So we have a progress bar. So the ID is progress bar, and we have a score. So do we have the score? Yes, we have a score here. It's 0/5. We haven't started yet, so the initial value is 0/5. And we have a clue container. So we have an equation box. The first clue is, of course, you have to solve these equations, equation 1 and equation 2. So the ID there is, the identification is equations. So we have the steps container. We have a class that we have a class also, the graph container. So we have an ID there, identification for the graph. So we can see a graph there for the web page. And of course, there's an interaction section and a hint box. Okay, so where's the interaction section? So in the interaction section, we can place, in this example, we can place our answers in a blank, or as we see further, where there's a variation of this, it could generate a multiple choice for us instead of blank. Okay, and of course we can have the PDF content. Later on in the discussion, I will show to you that everything here could be downloaded and it could be converted into a readable PDF format. And we have a link here for the JavaScript. Now the JavaScript file is has a name, app.js. It's essentially this one. So why do we need the JavaScript? Now to make, well, its main purpose is to add interactivity and logic to the web pages. So that's quite dynamic. So you interact with the web pages, and the code is written in the JavaScript file, which is the app.js in this case. Now let's try to analyze it. So here we have we have linear equations. We have essentially a system. We have two of these equations. Now, how do we generate this? Of course, we need to have a function that will generate the systems of a linear equation. And to define a linear equation, we need constants a, b, and c. So essentially, it's essentially something like a1, b, a1x, b1y, and c1. So it's essentially an equation of a line. And for the other equation, we have a2x, b2y, and c2. Essentially, it's also a linear equation. So combining two, we have a system of linear equation. Now this a and b and c are generated randomly by math.random. So every time that you will load the system and you answer another set of questions, it is different from the other, and it's quite unique simply because the system will generate a random coefficient for a value for the a, b, and c's. Now in the next lines, so how do we solve the equation? Again, we need to have a multiplier in order to make the coefficients the same and then proceed with addition or subtraction. Essentially, that's elimination method. Now, the best way for you to do that, okay, so this is essentially an elimination method. So here, it's a substitution method. So let's try to answer this first, and then maybe he can show to us some kind of elimination method, because this is quite random. He can choose between substitution method and elimination method. So here, let's try the correct answer, 2 and negative 0.2. So submit. So the solution is 2 and negative 0.2. So, okay. So as I have said, you could generate also multiple choice options for us. Now, is this elimination? Yes, it's elimination already. Now the method here is simply, if your equation is equation 1, then all you need to do is to multiply it by the constant a2. Now the constant a2 is the coefficient for x, so that's essentially here 2, and then you do the same thing for the other equation. If this is equation 2, you have to multiply it by the coefficient a1, so that's essentially 2 again. So if you multiply both of them, you will notice that, okay, the 4 there it can be cancelled out by subtraction. We leave leaving only the variable y, and then we can already solve it. In this case, y is equivalent to 1. So that's essentially this. So all you need to do is to subtract, okay, the corresponding terms, so that it will leave you with just a constant here at the right side, and the coefficient for y, you need to divide them. So essentially that's the numerator, negative 2, and the denominator is also negative 2. So that's y constant over y coefficient. So essentially this constant value on the right side, you have to divide it with the coefficient of y. So that's y coefficient. But of course, the coefficient is already modified. You need to have the multiplier. You need to take into account the multiplier, because what the multiplier does is to make the constant equivalent for the other variables so that you can cancel them. Okay? So in return, we have the solutions x and y. So upon obtaining the solution y equals 1, how do we obtain x? We substitute it back, and as you can see, the of course x here, we need the c1, that's essentially 3, and we can transpose it into the other side. This is b1y, and our y value is 1, so that's b1y, and we divide it by a1, which is the coefficient of x, which is 2. So essentially we form now the solutions, the unique solutions to the system of linear equation, and then we have to return that. So the solution is essentially x and y. for the coefficients that was generated randomly. So that's essentially the first function that we have discussed, the generate system function. Now there are several functions here. We have render math, update progress, show substitution steps, and show elimination steps. Here I have presented the show elimination steps. As you can see, we have presented the step-by-step procedure to do the elimination method. Now again, we need to have y coefficient and the y constant. So that's essentially, after multiplying it by the appropriate constant for equation 1, again we need to have the coefficient a2. So that's a coefficient for x in the second equation, and for the equation 2 we need the a1, the coefficient for x in the first equation. So we form now the y coefficient and the y constant by subtracting the corresponding equations, simply because they are now equivalent in their constants are now numerically equivalent. So in this case, 4x and 4x, they will be cancelled out, and what remains is just the y, so that we can solve it. So let's try to discuss it again. We have step 2, subtract the equations. From here, from the first step, we multiply the equations, essentially the multipliers here. We go on to the step 2, we subtract the equations. So if we subtract the equations, as you can see, after subtracting the equations, we can get the solution for y. So here, okay, essentially we are subtracting it. So we try to subtract the second equation from the first equation, so as to solve for y, and we now have the solution for y. And after we have the solution for y, we have to substitute it back to the other equation. So substitute it back. So here we have essentially the first equation, a1x plus b1, and the solution for y. Here the solution for y is 1 equals c1. So we can now solve for the value of x. So in this case, the web page will generate a solution. And how does he generate the solution here? There must be a function to generate the solution, so in multiple choice form. So let's try to find that out. So here we have a generate multiple choice. Now the generate multiple choice, if you try to analyze it, this short function, so it will just try to make a variation for the solution x and y. So as we know, the correct solution is x and y, and we increment that by adding a random number. So by generating it by that random, we can generate a variation of those, a variant of the solution that is essentially incremented. So it's not the solution itself, but somewhat it is candidate for us to put it in the multiple choice, and we have to iterate through all of that, okay, 4 times. So we need to append it. So that's the reason we have 4 choices here. So until we reach the 4th iteration, so we start with 0 up to 3, so it's a total of 4. And then, for example, the solution is 1 1. So if I choose the correct answer, it will say correct solution is 1 1. So there must be a mechanism here to check if the if we click the correct button for the solution, which is x equals 1 and y equals 1. So probably that is the check answer. So let's try to see what the check answer is. As you can see, the check answer, we try to compare the value that you choose from the correct solution. So that's is it correct? So we have something like an absolute value of the chosen answer from the correct answer. So the correct answer here is x and y. So he has set a tolerance of around 0.01. So your response has to be within the 0.01 tolerance so that it will be considered as correct. Okay? So if it is correct, of course the score is now appended. So is our score appended? So let's try to see. It's appended because we have a the score now is around 2/5. So we got 2 correct answers already out of 5. So we update the progress and then we show the correct solution. As you have seen before, it flashes a pop-up here that shows that the solution is correct. Now we proceed now to show the next clue. Of course, in the next clue, this is a substitution method. So the third question is we proceed to the next clue now, which is the third clue. We try to solve this equations, these systems of equations now, equation 1 and equation 2. Now this time we will use substitution method. So all we need to do is go to the substitution method. There must be a function here to describe the substitution method step by step. So let's try to find that out. Normally the function name will tell you what its purpose is. So it's a good function here. It is defined by its name, show substitution step. So it's good for you to define a function that will suggest its purpose. Here, the purpose is to show the substitution steps, so might as well name it as show substitution steps. Now let's try to analyze. So we solve using substitution method. So again, we see in the web page solve substitution method. Now here, we solve the first equation for x. So again, we see step 1 telling us that we solved the first equation for x. Now to solve that, all we need to do is, so this is c1, so we transpose 5y there, so that's essentially b1y, that's correct. So minus b1y, and we need to divide it by the coefficient of x, which is a1. So essentially that's correct, so that's the value of x. And then we proceed now to step 2. All we need to do is to substitute it into the second equation. And the second equation, that is a2 multiplied by your x. So that's 10 minus 5y over 2. So that's essentially, we put this part from the first step here. So it's identical, you see it here, plus b2y. Okay, b2y is equal to c2. c2 there is 10. And then we proceed with step 3. We simplify and solve it. We just try to distribute the 4 inside the parentheses. So that's essentially multiplication. So where's that here? So we have this one. So that's essentially multiplication. a2 multiplied by, okay, c1 b1 y. So this one is essentially c1 minus b1 y plus b2y equivalent to c2. And after performing the we distribute it, so essentially we group this common term, for the common terms, that the common term here is the y. So we have minus 10 plus 5, so we have minus 5, and then we have minus 10, so 10 minus 20, and then we divide both sides by 5 to give 2. So that's essentially this part. So After that, we have step 4, we substitute y back to find x. Now, in order for us to do that, we see that the original here means the original value for x is 10 minus 5y, so 10 minus 5, and we have to substitute the correct answer, which is the 2 this time. So okay, that's this part, so that's c1. So c1 here is 10 minus b1, which is 5, and the value of y here. So y, whatever the value of y here that we get, in this example that's 2, we have to plug that in, so that's 2, and we have to divide it by the coefficient of x, which is a 1, and that's correct. And then after a while, we now have the solution for x. So that's essentially the substitution method. And here we select the correct solution, so he generated the multiple choice type of question. So as I've said, it could have a fill in the blank form or something like a multiple choice form. So we need to choose the proper answer. Now what if, for example, you didn't choose the correct answer? So here the correct answer is 0 and 2, so this one, but you got sloppy and then you choose this other one, and we will have a pop-up and he will say that it is an incorrect solution, and the correct solution is 0 and 2. So okay, so what part of that the code is that? So it's essentially an incorrect solution. So he has to check the solution, of course, and if the solution is not correct, he will prompt you that it is an incorrect solution. So let's try to find that out. Incorrect. Okay, so he will give you an alert. The check answer, as I've said, it has a component which checks it, the answer is correct, and else if it is not correct, he will say incorrect. The correct solution is, again, he has to specify x and y. Okay, so the true solution is x and y. So here he mentioned the true solution, which is x equals 0 and y equals 2, and all we need to do now is choose the correct answer. So correct, the solution is 0 and 2, and again the score is appended. Okay, and as you can see in the graph, we have a plot of it, of both of the lines. So let's try to analyze that. So I think that's generate plot, somewhat like that. So we try to find that. Okay, there's a function graph. Now in the function graph, we need to, if you try to analyze it, so there are constants here, x and y, and of course the coefficients a1, b1, c1, a2, b2, and c2, and we need to have a chart. The data sets are essentially generated from create equation data sets. Now what is this create equation data set? So we'll try to find that. So here it is on top, create equation data set. Now here we analyze this, and as far as the code is concerned, we have to have an array to store the data points. So we need data points to generate the line. Okay, if b is 0, the equation is a vertical line, so it's a special case. So all we need to do is to set the b as 0. So all we need, all that is left out is just ax equals c, and so to get the x value where the line intersects the x-axis, that's essentially x equivalent to c over a. So we label it by ax plus by equals c, and then we specify the data points for the line, the color of the line. So we do not fill up the area under the line, so do not fill it. We specify the chart type as a line, and we do not display the points on the line. So all we need to do is to have that we utilize the data points by generating a line, but we don't essentially show the points anymore. So the function has to return a data set for the line with the corresponding slope. Well, we need a label, we need the data points, the color, And of course, don't fill the area, specify the chart type, and display points on the line and set the line width. So this is the return of the function create equation dataset. Now, assuming that that is a return, so of course we have the to label the solution. So we have the solution here, that's in green, and we have the data x and y. Now the background color and the point radius. Now you might wonder what is this 2196F. That's the color of the first. Oh, that's the color of the first equation. 2x plus 2y equals 9. The way to do that is, let's try to find out what color is that. So let's type it in Google. And as you can see from the color picker, okay, that's essentially blue. So you might guess that the other one is orange. So let's try to find out if it is orange, the color of the second line. Okay, let's wait for a while. So it's indeed the orange. So that's it. That's the essentially the color of the lines. Now let's get back there. Now, of course, there are as I have if you scroll through my mouse, we can zoom and pan through the lines. Okay, we can make it larger. So we have a zoom and a pan function. So we enable it to true. Okay, and after a while, so we play around with it. What will happen if we hit the total? Well, the score is a perfect 5. So let's try to do that. So again, it's a fill in the blank form. So let's try to put in the answer, 1.75, and this one is 2.75. Then try to submit. Okay. So again, he will have another clue, the last clue, which is substitution again, and then let's try that. So both of the answer for the x and y is 2.5. So let's try to input the correct answer. What will happen now? Okay, so it will give you congratulations. Now you are a master of the substitution and elimination method. You have a perfect score, 5/5. So where's that? So he will say congratulations, and you have a perfect score. Okay, so let's try to find that. Congratulations. Okay, so here we have there in the next clue function, after we hit the perfect score of 5/5, he will say congratulations, you have a perfect score. Okay, the correct answers. Now he will have a button here that is play again and download the PDF. So if we want to repeat everything again and do the elimination and substitution method, we want to have a review, for example, then you hit the play again. But this time I want to show to you that everything here would be retrieved and it could be downloaded in PDF format. So if I click this button, let's try to see what will happen. So I click the button. Okay. So as you can see, he's having a recollection of the questions that we have answered and the correct answers. And then there it is. We now have an automatic generation of the PDF file of the question and the answers. And here it is. We have the report along with the step-by-step solution. So this is quite practical. So the final score is 5/5. We do not have to take down notes anymore. The system will generate it for us. So essentially, we have demonstrated that Elimination and substitution method here in Algebra could be automated by using JavaScript by utilizing index.html and style.css to create a web page. Now, in the style CSS, it entails the styling of the whole web page, but this is you can explain it by yourself. So just like for example, the font family is Arial sans serif, the maximum width 800 pixel, we have a margin, we have a padding, and we have a background color. So again, in order to know for us to know the proper color of the system, all we need to do is to copy the number F8, F9. Then let's try to see what the corresponding color is. So what's the color of that? From the color picker, what's the background color? So it's essentially this white. Okay, so that's the background color. So we have the styles for the corresponding game container, equation box, step card, step header, choices container, input container, input field, choice button, the graph container, progress container, the progress bar itself. So in the progress bar, we have a height of 100% and a background color of 4CAF50. So I think that's green because the color of the progress bar is green. So we try to verify that. You can play around with the CSS or the styling code. Oh, it's indeed green. So we have the score here. The width is 100. We have the text alignment is at the center. So we see the score at the center. Do you see that? If we try to recall, it's indeed I think in the center. Yeah, the score is in the center of the web page. So we have a question. So we have the text format, action buttons, we have the PDF content, the PDF answer, and the rest of it. So I will try to copy everything and paste it in the comment section so that you have a feel of the styling of the web page and also the corresponding index.html and the JavaScript. This lengthy equation, I will paste it in the comments so that you can duplicate everything in the output of the program. So it's quite lengthy. It's already 38 minutes. So in the next session, we will discuss more on how to automate algebra by creating web pages. But for now, that's all, and thank you.